Hey guys, this is part 2 of the video and we're going to show you 2 examples now. Okay, so the first problem we're going to look at is this one right here. It says evaluate the integral 2x squared y dx plus yx dy, where c is the square with vertices 0, 0, 2, 0, 0, 2, and 2, 2. So the best way to approach this is by using Green's theorem. The first step you should take is to take the derivative of the second term with respect to x, which we did here, dvx is equal to y. Then you want to take the derivative of the first term with respect to y, and so d dy equals 2x squared. So Green's theorem says that you have to subtract the second quantity from the first one, so you have y minus 2x squared. And then you have to integrate that expression. So the boundaries are from 0 to 2 in both directions because that's the region that we were given. It was a square. And so you first take the integral with respect to x, which gives you xy minus 2x to the third over 3, and you evaluate it from 0 to 2, which gives you 2y minus 16 over 3. And then you take the integral with respect to y from 0 to 2 again, so you get y squared minus 16y over 3 from 0 to 2. And then you get 4 minus 32 over 3, and your final answer is negative 6.67.
Alright, so number 2, we're going to look at this problem. The question is, use Green theorem to compute the area of 2 petals of the 16 leaves rose defined by r equals to 9 sine 8 theta. The area of region D enclosed by our curve C can be expressed as A equals to 1/2 integral x dy minus y dx. So the very first thing you need to do is convert Cartesian to polar. So x equals to r cosine theta and y equals to r sine theta, as we've done multiple times. This is the first thing you need to do. And then because the question specifically mentioned we need to use Green theorem, and we are learning about Green theorem, we need to use Green theorem to solve the problem. And according to the Green theorem, the dx will become r equals sine theta d theta cosine theta dr, and dy will become r cosine theta d theta plus sine theta dr. So these are the usage of Green's theorem, and now all you need to do is plug x dx y dy into the formula given here. So, and if you plug it in, it becomes fx equals to 1/2 integral c, because we don't know the region yet, r cosine theta times r cosine theta d theta plus sine theta dr minus r sine theta times minus r sine theta d theta plus cosine theta dr. And if you simplify, it becomes half integral r squared cosine square theta d theta plus r cosine theta sine theta dr, r plus r squared sine square d theta minus sine theta cosine d theta dr. So these two things cancel out, and because cosine square theta plus sine square theta is only 1, it ultimately becomes half integral r squared d theta. And now we need to find the limits of the integral, As it specifically mentioned on the questions, we need to find the area of 2 petals out of 16 leafed rows. So as we all know, one rotation around the circle is 2 pi, and here you're going to figure out 2 out of 16 roses. So if you plug it in to this equation here, right here, then you'll get pi over 4. And your limit will be 0 to pi over 4. And now if you put the limit into the integral, then it becomes 1/2 times integral from 0 to pi over 4, 9 sine a theta to the power of 2 d theta. And if you plug it into the calculator, or if you carry out the integral, then you will get 81 pi over 8. Thank you guys. Hope you feel more comfortable with green theorem now.